Douglas, top of the morning to you. This is your Princeton Reverb Reissue and lovely tweed with an oxblood type of grill cloth. Just, it's a beautiful thing to behold, both visually and orally. And I think it's a shame that you're having some issues with her. We're going to flesh that out. You had mentioned that you saw some red plating tubes out back, accompanied by a reduction in volume. So, just to let you know, yesterday I began some stress testing in the absence of visually observing red plating myself. That's going to continue today as I remove the chassis from the cabinet. I'm going to be feeding in some extremely low frequency signals through the front end at volume. We will see what we can do to stimulate this issue, to see if we can get it to rear its ugly little head. But of course, that will be following a complete electronic inspection. We'll make a full assessment and see what's going on. But so far, the only thing I've personally observed was just a heap of noise in the reverb circuit. I mean, just bringing it up to 3, introducing a lot of buzz there. So we'll get this thing underway for you. Bye. And have a great morning. All right, here we are. We're going to liberate this chassis from the cabinet. We're going to get this service underway. And that is, as soon as I find my handy clamp. And I've found it. Okay. All right, Doug, and the rest of you mutants out there who may not know, maybe you don't. Maybe you don't. These plugs are problematic in many cases. I'll take a peek, make sure we're not going to have any issues. And we'll just take it from there. Excellente. Let's get this going. And we're back. Beautiful. You should always check your chucked up bit for wobble. So look for any wobbling. Just give her a good little slow spin. Heat it up. Observe the tip. If you detect any sort of wobbling, you get rid of it. Get yourself a new bit, because you will damage these fasteners as you try to remove them carefully. And it's not always appropriate to use a tool like this. And in this case it is. So there you have it. You just want to make sure that the fastener heads are perfectly clean, that there's no dust or funk obscuring your entry point for that bit. Otherwise, you're going to have some issues. And I think I went over this a few times in some other videos. You just scrape them out carefully. Use a little... I use like what appears to be like a dental appliance, and I actually have a physical dental appliance, but this is what I use by and large for the majority of work like this. And you'd be surprised at the type of funk that's removed. And once it's perfectly clean, the head of your bit just sinks right in. It's a beautiful thing. Let's get this guy out. You want to be careful because sometimes the way they've drilled the face plates on these for the front control panel, or the way they've drilled the speaker baffle, it'll literally catch onto it, and then it'll shred the top of that material there, a speaker grill. So you don't want to do that. Very nice. So I'll show you guys what we're working with here. Momentito. All right, shaky camera there. Let's power her up. And in this particular instance, I do have the current limiter engaged. She is warming up, and I have not connected the signal generator. I'm not going to start stress testing just yet. And we're going to be measuring ripple from the filter caps. Will I use the scope? Probably not today. Just going to use my multimeter, the benchtop one. But let's just get a quick sample. Let's get a quick sample of what. Get our levels up. All right. So I was experiencing a ton of noise in the reverb circuit until I removed the chassis. Let me see. Let me feel the cab and see which direction. Yeah. See what direction the jacks are facing on that tank. They should be facing forward towards the front of the cabinet. These are facing rearward. That's going to expose the input of this reverb pan to a lot of radiated noise from the transformers on this chassis. So we want to turn that around, and at the same time we want to eliminate the cables as well, being a potential source. But I would say that let's see, what are we looking at? They may not clear us here because with nothing attached, the driver's not really driving anything. And in the center of the frame here, you'll notice that I do have the driver tube socket. Let me move see if I can move this out of the way without injuring myself. I'll push it forward just so you can kind of see what I'm dealing with here. Get this one out the way as well. So, you know, Fender likes to, if they're running stuff in parallel, they're gonna use little bus wire jumpers, or they'll just strip a bit of extra length off the leads and then jump across the socket. You know, you'll go grid to grid, plate to plate, cathode to cathode, whatever they're jumping. In this case, you'll also notice something that they do that is not a best practice. What am I referring to? Let me grab a chopstick real quick. The best practice for this type of arrangement is to keep the grid wires as short as possible and as far away from any source of radiated noise, such as these filament wires here, which are nicely twisted. So thanks, good job, Fender. And you want to keep them away from other things as well. Say some of the higher current or voltage bearing leads coming from some of the transformers, like in this one in particular. So what do we want to do? We want to make sure that we're not jumping the grid outside of the socket like this. We want to make sure we're not doing that. That's just not what's going on here. What they've done, and what they tend to do in these reissues, is they tend to jump the plates with that short wire, and then you'll have at the opposite angle here, crossing over, you'll have the cathode, which is not really a consequential lead to be concerned with dressing. However, what we want to do is we want to switch these. So we'll repurpose this jumper for this blue plate lead here. We'll remove that jumper, and what we'll do is we'll jump the grid itself across, perpendicular, mostly perpendicular to that cathode lead there. So that's what we'll work on, and it's going to need it because the reverbs is largely unusable at this point. Bye. All right, let's see what we're getting in terms of ripple. You want to grab your meter. I'm not going to use my scopes for this. You're going to grab your meter, and you want to set it to AC volts. Ripple will be obviously AC. Why do they call it ripple? Well, because it looks like a wave. And what's a wave? It's a sine wave, and it's representative of AC voltage. So the job of the filter caps obviously is to store what they call pulsating DC, which comes off of the rectifier, and further smooth that ripple. And hopefully by the time it's filtered all the way down to the plate supply on your preamp end, you just have steady, linear, fresh DC being supplied. So let's look at what we're looking at here with respect to AC volts. This is a 6.5 digit multimeter, so it's going to be incredibly sensitive. So you want to pay attention to the decimal mark there. Okay. So we'll start at the power amp end, the reservoir caps, where we expect to see the largest amount of ripple, and that's normal. All right, let me get myself sorted out. I did not clip in my ground as I normally do, so I'll just, pardon me, I'll just have to physically hold it there. So we have about 3 volts of ripple there on the reservoir. And then moving over to the next, which I'm not looking at the schematic right now, which may be the screen supply. We have about let's call it a half volt of AC. Let's move over to what should be maybe the phase inverter and reverb plate supplies. And we're down into the millivolt range. Let's call it 40 millivolts. Not bad. Let's come down to the preamp plate supply. And we've filtered all the way down from what we called 40 millivolts down to, let's call it 4 millivolts. So 10 times less. That's acceptable. That's more than acceptable. These blue Illinois caps that are in some of the latter Fenders are a hell of a lot nicer than their gray counterparts. So they're a step up in quality if you look at the spec sheets. So we don't treat all Illinois the same. Illinois actually makes beautiful caps on the mid to high tier caps. They're great caps. And you'll see a lot of guys, like Mr. Carlson, for example, if you guys fancy yourself test equipment, you'll notice that he uses the mid to high tier Illinois caps in a lot of his restorations. And that speaks volumes about the quality of their mid to high tier product line. But it also kind of, on the back side of that, it tells you to avoid the low tier stuff. So shame on you, Fender. This amp was assembled in 3rd day of the February 2021. It's not an old amp. She's holding up well. I'm not seeing any charred or burned or stressed components. Circuit board looks great. But I think I need to move forward with a stress test. The current limiting bulb, located, according to your perspective, northwest, is indicating a very easy, gentle, and what I would call, what I would expect to see out of this particular amp. So very dim, very dim. Let me just break you off there and you can take a peek. inch out of there. See? And this is indicative of what I'm seeing myself. The camera's not embellishing or exaggerating the color of the filament there. So, all right.